40% of your payment requests are failing, but your alert dashboard shows green. That's what happened when a team silenced a high 5xx rate alert that fired every deploy. 3 weeks later, a misconfigured load balancer caused a 45-minute outage nobody saw. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover alerting on-call best practices. Alerting and on-call is the practice of detecting when your production systems are in trouble and routing that signal to a human who can fix it. The core challenge is engineering the signal-to-noise ratio so that every page matters. The most common mistake is alerting on causes like CPU instead of symptoms like error rate. A high CPU alert doesn't tell the engineer what to do. A high error rate alert does. Always ask, would a user feel this? Here's a symptom alert that fires when the shopping cart error rate exceeds 5% for 2 minutes. The for duration filters out transient spikes. The runbook URL gives the engineer immediate next steps. A healthy rotation needs at least 4 engineers to give genuine recovery time. Secondary on-call is non-negotiable for any SLA-backed service. Handoff meetings ensure knowledge doesn't live in one person's head. This Terraform defines a 3-level escalation policy. Primary gets 10 minutes, then secondary, then the engineering manager. If secondary escalates more than once a week, your alert volume is too high. Runbooks should start with the first command to run, not architecture context. SLO burn rate alerting pages you only when your error budget is at risk. Multi-window expressions prevent transient spikes from triggering pages. This fast burn alert fires when both the 1-hour and 5-minute windows show a burn rate above 14x. The multi-window condition prevents a short spike from triggering a page, but catches sustained problems. This is the same issue we highlighted at the start. Here's exactly why that happened. The team silenced a high 5xx rate alert that fired every deploy. 3 weeks later, a load balancer misconfiguration caused 40% failure for 45 minutes. Because the alert was silenced, no one was paged, and the dashboard showed green. The fix is to never silence an alert for more than 24 hours without a linked ticket. The root cause was a deployment process failure. Fix that, not the notification. Use temporary suppressions only during active incident response. This CPU alert fires on any spike, often from batch jobs or GC pauses. The engineer has no clear action, just CPU is high, so they learn to ignore it. Delete this alert and add CPU to a dashboard instead. A single window burn rate alert can fire from a short spike that self-corrects. The 1-hour window still sees the spike and pages the engineer for nothing. Multi-window avoids this by requiring both windows to be elevated. Silencing an alert without a linked ticket is a ticking time bomb. The underlying issue continues, but no one sees it. Always create a ticket and set a max silence of 24 hours. The for duration in Prometheus alerting rules, e.g., for 2M, is supported in Prometheus v20+. In earlier versions, this field is ignored and alerts fire immediately. Ensure your Prometheus version is v20+ to benefit from noise filtering via for. The article warns against silencing alerts, but doesn't show how to prevent silencing from hiding outages. Use Alert Manager inhibition rules to suppress lower severity alerts when a critical alert is firing, ensuring the outage is visible even if a specific alert is silenced. The article mentions alert fatigue, but doesn't quantify its impact. Studies show that on-call engineers experiencing 5 non-actionable pages per week have 2x higher burnout risk. The 3AM test and monthly audits directly combat this by reducing noise, which is critical for team retention. The article describes runbook structure but doesn't provide a concrete template. Here's a minimal runbook template in Markdown that can be linked from alert annotations, covering the 3 essential steps: confirm, mitigate, escalate. Use AmTool to add silences with a ticket comment and auto-expiry. Query existing silences to find forgotten ones. Regularly audit alert labels to ensure correct routing. Let's run through some common interview questions. What is the difference between alerting on symptoms versus causes? Symptoms are user-facing latency, errors. Causes are infrastructure metrics, CPU memory. Alert on symptoms. How does multi-window burn rate alerting reduce false positives? Requires both short and long windows to exceed threshold, filtering transient spikes. What is the minimum team size for a healthy on-call rotation? 4 engineers minimum to allow recovery time between shifts. And a few frequently asked questions. How long should a for duration be? At least 2 minutes for critical alerts to filter self-healing issues. What should a runbook contain? 3 steps. Confirm it's real, apply mitigation, escalation criteria. How often should we audit alerts? Monthly, delete or fix alerts that fire 3+ times without a code fix. To recap, alert on what users feel, use multi-window burn rates to avoid false pages, never silence without a ticket, and audit your alerts monthly. These practices build a system your team trusts. Ready to go deeper? Up next, log aggregation best practices, then chaos engineering basics, then introduction to Ansible. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.